Hi students, today we will discuss the dot product of two vectors, dot product or scalar product of two vectors. So in our earlier class, we have already discussed about the vector product of two vectors. So here we will be discussing the dot product or scalar product of two vectors, which is very important to solve the questions in physics, and this is a very important mathematical tool. So now quickly we'll go through the previous topics that we know. Any vector, suppose A is a vector, so we'll be discussing this is dot product, or this is known as your scalar product. So you know, suppose any vector A, so it will have its three components, that is your x component I cap plus y component j cap plus z component k cap, right? Similarly, suppose the second vector is given, here B is equal to bx I cap plus by j cap plus bz k cap. So if we want to find out the dot product of two vectors, then the formula is that dot product of two vectors is given by AB cos theta. So here, what is A? Magnitude of A. What is B? Magnitude of B. And what is theta? The angle between two vectors A and B. So graphically, if vectors are given like this, suppose this is your A and this is your B, then the angle between them is theta. So the dot product of two vectors A dot B will be equal to AB cos theta. Here the result is a scalar quantity because there will be no direction. That's why this is also known as a scalar product, right? So similarly, if you are given the components as discussed here, so we can find out the dot product will be the product of their respective components and adding them. So we'll be getting ax bx plus ay by plus az bz, right? So these are the two different methods to find out the value of dot product of two vectors, right? So now we'll be discussing its applications or properties. So you see here, properties. So first property you see here, suppose we are getting two vectors are perpendicular to each other, So what will be the value of their dot product? So dot product is equal to AB cos, perpendicular means theta is equal to 90 degree. So here we will see AB cos theta. So you know cos 90 is 0, so this will be 0. So this is a very important concept. So here we can say if two vectors are perpendicular to each other, then the vectors are perpendicular to each other. Clear? So this type of questions also asked. Suppose one question we'll discuss here. Suppose it is given a vector is there, suppose 2i cap plus 3j cap minus 5k cap. Similarly, B is another vector, suppose this is I cap minus 3j cap plus mk cap. So in the question it will be asked, if these two vectors are perpendicular to each other, then find the value of m. So how to find out? Now if it is given ki A is perpendicular to B, so that means you can say that A dot B will be equal to 0. So here you find out what is A dot B. This component will multiply. So 2 into 1 plus, here this will be 3 into minus 3 plus, here you will be getting minus 5 into this is your m, and this will be equals to 0. So here we will get 2, this is minus 9, this is minus 5m equals to 0. So imply that you will get minus 7. So that side will be 7. So minus 5m is equal to 7. So implies that your value of m will be 7 upon minus 5. So this is minus 7 by 5. So this type of question is asked normally. This is very important, right? Now we'll be discussing the second property, that will be here the dot product of two orthogonal unit vectors. So you know what is orthogonal unit vectors? Already in our previous class we have discussed I cap, j cap and k cap. So if you are having a three-dimensional expressions, then x-axis the direction is given I cap, that is the unit vector. This is j cap, this is k cap, right? So if we are given I dot I, so you know the magnitude of the unit vector is 1. Here this will be 1, and these are the same vectors. So what is the angle between I and I? That is 0 degree. So cos 0 degree, you know, this is your 1. So all the value after multiplying will be getting 1, right? So dot product of two similar orthogonal unit vectors will be 1. Similar manner, if I want to find out I dot j, so you know this will be 1, this will be 1, and the angle between the two vectors, that is I and j, that is x-axis and y-axis, so this will be 90 degree. So we can write here cos 90, so this will be equal to your cos 90 is 0, so this will be 0. So this is also very important. So here we can conclude that the dot product of two orthogonal unit vectors similar type, that will be 1, and the dot product of two orthogonal unit vectors different, they will be, that will be 0, right? Third property is here, any vector, if we are finding out the dot product of the two same vectors, then what it will come? It will come as the magnitude of A will be A and magnitude of A will be A, and the angle between them is 0 degree. So this is cos 0 degree. So we can say this will come as A square, right? So dot product of two similar vectors will be the square of that vector magnitude. Clear? Now another important thing that we are going to find out, that is known as your projection. That is known as projection. So what is projection? Suppose, as we have discussed, suppose this is your A, this is your B, the angle between them is theta. So I can say here, you know the concept of rectangular components of a vector. So if a vector is given, so we can find out its two rectangular components. The horizontal component is your A cos theta and the vertical component is your A sin theta. This already we have discussed. You can see here, suppose we are having a coordinate system. This is a vector. So suppose this is your R. So if it is making an angle theta, so the horizontal component will be your R cos theta and the vertical component will be your R sin theta, right? So if I resolve this B vector into its two rectangular components, now you can see this component will be your B cos theta, right? And this component will be B sin theta, but we are not considering, here we are talking about the projection. So here we can tell the projection of B on A, that will be your B cos theta. Clear? So projection of any vector. So here I can write the projection of B on A. So this will be equal to your B cos theta. This is also very important. And by using this concept, some questions asked.